I would like to welcome you to this online science cafe. As you all know, that the theme tonight is Meteor Showers of Summer 2021. We'll have some new kids on the block. Alexander will say more on this. I'm glad to have you again. So just to remind you, every 2 weeks, we do our online science cafe, free of charge, for open to the public. So the next one is going to be in 2 weeks' time. We will announce what's going to be on at the end of the session. And every time, as you know, we have a speaker, a guest speaker. This time we have many speakers. And it's going to be nice and intriguing. So, Alexander.
Okay, let's proceed, most probably. So I wanted to show the first picture. And if some of you could not see it clearly, I'll put it in chat. So I took it from International Meteor Organization. So you may, now it is in the link, so you may proceed now with it. Okay, I should close my chat. Yeah, here we are. So this picture was taken during some time when you put camera, open it for certain amount of time and then close it. So it looked at the sky, and we could see that because of the movement of the sky, some stars left tracks. So like this or this, or how I, for example, recognize which stars are where. I look at the beginning of track. So this star, this star, this star, and so on. And it tell me, but this should be Big Dipper. So this is Big Dipper. And if it is Big Dipper, then this should be Small Dipper, how you call it. So, and this is definitely Polaris. So then we could say that the one circle around Polaris should mean 24 hours, but this is not one circle. It Cohab, for example, was opened here and closed here, so it's about 1 hour and a half, something like that. So that's duration how camera was opened at. And as we could see, there are some not only parts of arcs, just parts of circles, arcs, but there are some lines on this picture. It means that we have meteors. So during this 1.5 hours while the camera was opened, some meteors were so bright that they left tracks same brightness like the whole track of the during 1.5 hours of the whole star. For example, this one, or this one, or maybe this one. Okay, these are simple. It's easy to find. That's the reason why I sent you the picture in case you wanted to follow it, so you may open it larger at your screen. But we have this one as well. So it was not something wrong with camera. No, it was another one more meteor which just coincided with the track of a star. And we have one more. Have a look. We have this one. Very tiny, but there is one. And one more. Maybe you may see more. I don't know. But it's really impressive. A camera which could not take pictures of all meteors which are visible by naked eye. Only bright meteors are here. And it took just during 1.5 hours, how many? 7 meteors. It's really incredible. And we may notice that actually it's obvious that if this is Big Dipper and the handle of Big Dipper opposite to it, there is Cassiopeia. So these stars are from Cassiopeia zigzag. So it means that these meteors, 1, 2, 3, they started from area beyond the Cassiopeia, which is Perseids. So we found the mystery of those 3 meteors. They are from Perseids. And now our first talk is about Perseids, presented by Matvey Dubishkin, Perseids and minor meteor showers.
Hello? Hello?
Hello, yes, Matvey, we hear you.
Okay. 1 minute. Mm,
Welcome, Matvey.
yes, on it.
Share your screen.
Okay, do you see?
Yes, perfect.
Okay. So yes, hello everyone. Show my presentation about the meteor showers and minor meteor showers. Okay, let's begin. Okay, what's meteor? So we have a meteoroid, which is a small rock or metallic body from outer space, which is smaller than asteroid and larger than space dust. So when he enters the atmosphere, he becomes visible. So it is bright and so it's become visible, and we see a line in the sky. Sorry, my English. So about meteors. So we have here a Perseids, which is one meteor shower. So at August, we can see the Perseids. So yes, so we can see here the dates when the Perseids is visible. So it's between 11 and 15 August, somewhere here. The IMO website says that peak of Perseids it's at 11 and 12 of August. So I observed the Perseids. Here is my observations at 11:30 of August. So at the first observation, which at 11, I saw only one Perseid, in total 5 meteors. Wasn't, so it isn't much. In the second observation, I saw 10 Perseids and 16 total. So why is in first observation I saw only one and second 10? So in my first observation, I started very early at 9:30 o'clock. So when the Perseid radiant from which becomes the Perseids was very low, only 10 degrees altitude. So in a second try, I begin my observation at midnight, 30 August, when the Perseids radiant was 25 has altitude 25 degrees, so it's very high. So that's why in first try I saw only one person and the second 10. Okay, now about smaller meteor showers. So I also observed Southern Delta Aquarids and Alpha Capricornids. So peak of these meteor showers was 28 and 29 for July. So we can see here. So, and I observed them, and I saw only in the first observation I saw only one Capricornid, one Perseid, and nothing more. And the second, I saw only two sporadic and nothing, nothing from minor meteor showers. So this happened because this time I started observation when the radiant of these meteor showers was very low. So I saw one Capricornid because his radiant was pretty high, and I saw no one Aquariid because at the start of observation the radiant was below the horizon. So what conclusion we can do? First, during observation, radiant should be as high as possible. So in Perseid case, start the observation as late as possible. Okay, second. There's many others meteor showers, because yes, and third, we have sometimes some outbursts exist. So wait a minute. We have some meteors and in days, not only at the peak days. So we have some here and some here. Yes. So this is my presentation.
Thank you, Matvey. Any questions?
Yes, I have a question regarding the table that was being shown. Is it possible that you can explain what was included in that table? Because I was looking at some of the abbreviations and I was not familiar with those abbreviations. Can you explain what that table contains actually?
The SDA and the CAB.
There were two tables which you
Can
showed. Yeah,
yes, this one.
yeah, this one, right?
Okay.
So it says in Capricorn, it says M and N, and Perseus M and N. What does M and N stand for?
Where? Here?
The method.
Yeah.
Method and number, yes.
And number, yes.
It's a number of meteors.
And M is what?
How much meteors you saw?
No. M means method, method of
Count.
registration. In this case, it was counting. We watch, we look at the sky and count how many meteors we got.
Okay. So what other methods are usually used?
It's possible, for example, make video or photographic, or to make plot or make direct measurement of meteor of this very specific meteor. So there are others as well, and IMO proposed in this case only, not only, different as well. You may put others if you use them, but for our purposes, it's counting is enough. It's okay. And could you explain, Matvey, other graphs there? Magnitude distribution, for example. No, at the same table.
Here?
Yeah, magnitude distribution. What does it mean?
Okay, I observed only from my house, not which have a lot of lights, and I saw only bright meteors.
And how bright were they?
Okay, in first observation I have two meteors, 0 magnitude, and the second one meteor with -1 magnitude, and second with +1 magnitude.
Okay, so it is standard magnitude rates of luminaries.
Yes.
And Matvey, you may also show with your cursor the limited magnitude for your observation.
Yes.
Omer.
So first, I watched the 5.5 and second 5.
So when it was darker.
What?
And on the left-hand side for the limiting magnitude, it says F. What does F stand for?
If here is a clouds or something else which like clouds.
It is a visibility factor, Omer. So
Okay.
you divide 1 divided by 1 minus the percentage of the coverage of the eye. If, for example, you have 10% covered by clouds, then it's 1 minus 0.10, and the answer, you divide the answer 1 divided by the answer, and you get the percentage. You get this factor. So one means that's 100% clear. If you 50% covered, then 1 minus 0.5, 1 divided by 2, it means 2, so 50% is covered, so 2, the factor was going to be 2.
Thank you very much. Thank you.
And Matvey, what does it mean, RA and DEC?
It's which where I was looking at the sky. So the point where I was looking at the sky.
Okay, and RA is for coordinate right ascension and DEC declination.
Yes.
And where do you take these numbers?
And stellarium. I use stellarium. I found the nearest star at from the place I was looking, and used it as coordinates.
So this is coordinate of a star which was very close to the center
Yes.
field of view. And just coordinates, nothing
Yes.
more. Okay, so as I understand, we have the first column when you started your observations, the second when you've ended, then how long you observed, so 15 minutes, then where you
yes.
look at, then where there were obstructions, no obstructions, if it's one precisely, limited magnitude, which means when it is 6, it should be dark sky. When it is 5.5, it's not very dark, but reasonably dark. It's nice sky. But on the left, on the right observation, it is 5, so it was brighter.
Yes.
The sky generally was bright. Well, so that's all. And magnitude distribution means just
Magnitude of meteors.
of that meteor. How do you know that the magnitude was 0, for example?
I use the stars which have some magnitudes, and I
Сравнить, compare.
Compare them.
So he compared just meteor.
So I know the stars which all of these magnitudes, and I compared the meteors magnitude, and I found.
So 0 means very bright, so like Vega. So he compared with Vega, and if it is suits, okay, it is 0. We put 0 for it. Well, more other questions or more clarification if necessary, Omer?
No, thank you very much.
Okay, other questions? Well, then let's proceed. Thank you, Matvey.
Okay.
Could you, maybe when I start sharing my screen, it will stop sharing others. Okay, so what we have in this year, there were maybe today figures change, I don't know, but there were at least 77 observers, and we had already 2,000 Perseids registered, and this is from Cyprus. I'd rather say that there are many places where Cypriots go around and observe the sky. So it's really impressive. It's much more than we had many years ago, just 1 or 2 places. And let me give some more talks, some more words before we proceed to the next. Here is the list of participants who already registered here, but I believe there are some more who did not put their data yet. Well, and you see, Matvey already discussed that there are regular, every year, meteor showers. There are very famous Perseids and others as well. But together with this, there are once in a life experience when we could see a meteor shower produced by a trail of a comet which just passed now next to the Earth. And it happened with one comet this year. And Leonidas Constantinou will give talk about first revolution dust trail of comet, let me Chacornac. It's French name. Chacornac discovered it. Okay, Leonidas, could you proceed?
Hello, everybody. I'm going to talk to you about the one revolution dust trail of Comet 1852 K1. So as you can see, on the 12th of August, it was predicted there will be a meteor right here from this radiant, among which are the Perseids right here.
It is the last slide. So move back. Yeah.
Yeah. Okay. Right here, there will be a meteor from this radiant, among with here, which are the Perseids. Right here are my observations from the 11th to 12th of August. Here is from the 11th. I observed one meteor from the comet, which was new. That's why I had to add it right here. The magnitude of that comet was 2, which was 1, and the velocity was 64, which was quite fast, which is faster than Perseids. We can distinguish that the meteor was from this radiant, as I observed it coming just below Jupiter, and we can tell it was from the meteor from that radiant, as if you come back right here, it will be from that radiant. So yeah.
So thank you. And if you have questions to Leonidas, welcome.
Yes, that's great. Thank you, Leonidas. Good job. Actually, many people didn't know about this comet, as we also didn't expect the outburst, not from the comet, but the outburst in the next day after the maximum. And Leonidas actually mentioned something very important: the speed of the meteors from that radiant from the comets. It was 64 kilometers per second, whereas Perseids, which are very fast, they achieve 59 kilometers per second. So you could also distinguish them, yes. And it was really nice to observe these meteors in the morning and distinguish them. They are very distinguishable, and we are very happy actually to be able to record these outbursts with our team. Congratulations.
Some more questions or remarks?
Do you record the observations as you're doing them, or do you record them and then input them into that table? I don't know if...
As we're doing them, we do record them with a photograph or from the phone.
Oh, and then
no. The question is, how do you record it? Most probably. What's the procedure?
Visual.
Yeah, it's visual. It's visually. We have a piece of paper, and every time we see a comet or a meteor, we write them down and the magnitude together.
And then you put them into the table.
Yeah.
Okay, yeah.
And this table is online, so you may put it on IMO site itself any moment.
Okay, thank you.
Good job, Leonidas. Bravo.
And Leonidas, could you show your last slide again?
Yeah.
And because of it is your slide, and that's why it is you who could move cursor. Yes, could you show horizon from east to the bottom of picture? So the red line. Yes, this is horizon. And have a look. I participated that time in observations as well. And for me, it was really impressive to see that all meteors coming from the sky, from the top, and only from this radiant, they are coming from bottom, from horizon. So anything which goes to the sky, it is from this meteor shower. And I saw same day as well 2 meteors. I don't remember, maybe 3. So anyway, I supplied them to International Meteor Organization as well. So it was really interesting to saw these meteors in the completely another way how they behave. So everything goes on the sky itself, but those rise from horizon. Well, thank you. And let me proceed then. I'll share my screen. Where we are? Here. I could share my screen. Yeah, here we are. Well, so Chacornac comet is elliptic comet, so parabolic, so its trajectory, or elliptic, I said, sorry, its trajectory is parabolic. So it arrived one time, it happened in 1852, and passed by the Earth somewhere. So I don't know where the Earth was that moment. Most probably they did not meet. But that's what found out later, as I understood, based on the images of comet, that when it passed on the Earth's orbit, was the same distance from the sun as 1 astronomical unit, some dust particles came out from the comet, and they found out that they should return back again to the same place this year. And that's why next year we will come here again at this place, but we would not meet them. We would not meet those particles anymore. And no, next year, I'm not correct. So the prediction was made at the end of last millennia, and for almost 100 years in advance. And with this comet, the Earth would meet with its trail only twice, this year and next year, and after that, no. So maybe in some 100 years, I don't know. Well, anyway, but next year in 2022, it will be same time, but unfortunately, same time, it will be full moon. And that's why the observations would not be so nice for us. So that's why this observation this year, it's really interesting. So we caught sending remains from that were events which happened in 1852, but we caught it now. It's really impressive. Okay, as far as I understood, we are coming closer to ending of our visual observations, and at the end I want to show you one more interesting phenomenon, which was about gamma draconids. So this meteor shower was first discovered in 1963, and since that time it gave one outburst in 2011. That year there were 25 meteors observed during the season, and based on it, it was confirmed that yes, this meteor shower exists. It produced outbursts, and in 2016 you may see that the outburst was completely incredible. It gave 100 and up to 100. It was, but unfortunately, it was just during half an hour. That's all. So it gave a short outburst. And this year, we expected one short outburst again about same time on the 28th of July, and it was observed. So based on those 25 meteors in 2011, the reconstruction of the parental body which produced these meteors was made, but it does not connect with anything. Till now, we don't know any comet which could make it. And this year, Robert from the United States, he observed this very July gamma draconids exactly on the night when we were in Cyprus in Ayas Theodoros, and during break I saw as well gamma draconid. So they're rare, but for this year we expected an outburst. So we confirmed, being in Cyprus, that outburst was absent that time when we observed, and Robert confirms that one meteor is not outburst. Of course, it's not many. So, but there are some, at least from this meteor shower. So we really know that it exists, and the day when it was predicted, it was active, but maybe it was active other time, which neither in Cyprus nor in the United States got opportunity to see. Okay, now we are coming to our photographic, most interesting part of our discussion. And could you say some words, Philippos? Philippos is founder of Larnaca Photographic Society, so he knows a lot about photography and very, very much about meteors. So welcome.
Thank you very much for the invitation. I'm gonna share my screen. Okay. Basically, what I will show you, it's the photographic side of the meteors. No scientific, no nothing. I'm gonna talk about my equipment and about some photos and locations that we took some nice meteors. Okay. Just a second. Okay. Okay. This is my equipment. Basically, I'm using two DSLR bodies, a full frame and an APS-C sensor camera. My favorite lenses, it's 1530 2.8. 2.8 is the aperture of each lens. The smaller the number, the faster the lens it is. It means that more light can enter the sensor and take easier and better photos during the nighttime. For the last 3 meteor showers, I started using the Skywatch Star Adventurer, which it's very easy to use it because you are taking one position of the sky. You have all the meteors that are passing from that position, and then it's easy for you to stack them at their exact location. And also, for the meteor showers, you need to be equipped with a lot of patience. If you are not patient, you are not succeeding anything. This is the setup I used for that year. I used my Star Adventurer. I had my one camera facing at the Milky Way because it's, from what I heard, if I'm wrong, correct me, Alexander, at the beginning of the night, before the peak, the largest particles enter the atmosphere and they are passing much above the radial point. That's why facing the Milky Way, we managed to take some really nice and big strikes of meteors. I had the one camera facing the Milky Way and the other camera was facing almost at the radial point. It was difficult to achieve it because very heavy equipment and a small, the Star Adventurer is quite small for these things, but I managed to balance it and it helped really much. I will show you the results later from this. I also call this dream catcher. This is a photo that I took at the sanctuary of Apollon Hyades in Limassol in 2015. For that night, we were so crazy that we paid for the government money to bring us person to be there with us so that we will be at this place for the whole night. 2015, it was a great year. This is my favorite photo until now. I took it in 2016 in my hometown in Xylophagou. Very nice bolide, it's very nice. This is a photo from last year. It's a shooting range in my hometown again. We can see here 3 large meteors passing near the Milky Way. And this year, this is from that year, I managed to take with not so wide angle. I was at about 35 millimeters, 2 very beautiful Perseids. You can see the colors green and yellow, much detailed. This is again from this year. I was using my Star Adventurer. I had it positioned at the radial point, and then I came and stacked those photos, those meteors at their exact location. Basically, that's it. And I'm closing the presentation with this, Alexander. It's an unknown meteor. For sure, it's not Perseid. I'm waiting for you to explain what is it. We spoke about it yesterday. If you have any questions, you can share them with me. Thank you.
Felipe, thank you very much.
Paragalo.
Very interesting, great images. And I would like also to thank Philippos in public that he lent us some of his pictures for the website as well. Alexander?
Yes, I remember this very photo. Philippos, could you share it again?
Okay, sorry. Okay.
Okay, could you show Big Dipper? 3 stars visible in the off handle of Big Dipper.
Just a second. Really to Alexander more.
Αν την έχεις μόνη της.
Έχω την αλόγηση του το computer.
Okay.
The Big Dipper, Alexander μου, probably.
3 stars over the tree, the lower tree.
Κάτω δεξιά, φαίνεται πριν τον Αρτούρο. Μου φκένει δεξιά σου. Πάνω από το μόνο του.
Περίμενε.
Ναι, αυτό είναι Αρτούρος.
Όχι, αυτό είναι...
I don't see.
Πάνω Αρτούρος. Έλα δεξιά πάνω.
Δαμέ.
Έλα δεξιά πιο πάνω. Πιο πάνω. Ναι. Φαίνεται το κέρσος σου. Τράξε το κέρσος σου λίγο δεξιά πάνω από δέντρο το μόνο. Δεξιά. Λίγο πιο κάτω δεξιά πάνω από δέντρο. Κάτω δεξιά, κάτω πάνω από δέντρο.
3 stars over the tree. I don't see the tree.
Τράξε το λίγο κάτω δεξιά.
Yes.
Φαίνεται το κέρσος.
Όχι, φαίνεται.
Πιο δεξιά. Λίγο πιο δεξιά πάνω από δέντρο το μόνο του.
White tree.
Περίμενε,
There's a big tree to the right side of the middle.
Μπράβο, τζάμε.
Yes.
Right? And it's
And over it,
περίμενε, για δαμέ που λαλείτε, ναι. And George μου, the single tree, the 3 stars above the tree.
yes, exactly. So
Okay.
this is Big Dipper.
Big Dipper.
And it means that the meteor comes from either Southern Delta Aquarids or Capricornids or antisolar radiant. They are very close to each other. From this distance, I could not distinguish which 3 of them. But what really we could do, and I need just a student, I mean school student, because of others, this task is for school, not for elder. We could develop a program which might do such thing. We will put coordinates of meteor, beginning and end, celestial coordinates, and that program will tell us from which meteor shower this meteor comes from. So it's very simple, it's just few calculations, but because of it is a lot of sine and cosine, but to do it with computer, not with yourself, with your calculator. So, so it means that if some students of school age, Lyceum students, you may invite them and we will develop such programs. Because of Philippos asked me what's about this, other people ask, so we had now these days so many photos that it's time to make this estimation as routine.
Maybe there is a ready application, Alexander.
Yes,
maybe if we search about it, we might find something.
Maybe it exists, but wait a bit. One thing is to find something. Another thing is to teach a student how to do it by himself. It's completely another story. I know how to do it, so let him do. So things like that.
Share knowledge and create outreach.
Yes. Thank you, Philippos. Some more questions to Philippos.
Yeah, I have a question, Philippos. You said that you've used wide angle and not so wide angle lenses as well. So which lens has given you the best satisfactory pictures? Is it the wide angles or is it the ones that are not wide angle?
Omer, look, if you are using a wide angle, for sure you are catching more sky and you have more chances in achieving to take a photo of a meteor. If you are using, let's say, a 35 or 40 mm lens, you might need to be luckier to take a photo, but it's going to be more rewarding. This is the difference. If you are using a wide angles, for sure you have more chances to manage to take a meteor. If you are using longer lens, it needs some luck, but the photo you will take, you will be more rewarding. That's for sure.
because it's capturing less area on the sky.
Yes.
Thank you.
Some
You're
more
welcome.
questions?
Any more questions for Philippos? Okay, great, Philippos. Yes,
Okay,
Alexander,
thank
we are
you.
proceed. Thank you, Philippos.
Thank you.
Thank you very much. Okay, let's me proceed. So we now know how to take pictures, not just for long time, but for short time, but with meteors, if you have patience. Okay, now I wanted to present one more speaker from Qatar, and I was really impressed that Karen made us familiar, and we proceed further with some talk, and we should say thank you to Facebook as well, because of it really united people. And Omer made a lot of beautiful pictures, took a lot of beautiful pictures that it's impossible to know that, not allowed him to share his beauties. Okay, welcome.
Thank you very much. So I'll share my screen.
Yes, welcome.
Yes.
It's okay.
Great honor to have you with us, Omer.
Thank you so much. Right? So this, I've made a slide deck for today's talk, and I've named it Perseids, Showers, and Arabian Nights. Arabian Nights because I'm observing it from the Middle East, right? But rest of the presentation will be about Perseids shower. If you want to know more about Arabian Nights, you can contact me later, and we can talk about those.
We would love to, Omer, and maybe we can do a special dedicated event, Science Café on that, and you can talk about us specifically. We would love to. And maybe we can exchange some observations. Maybe you come over and we come there to visit you as well and do some observations and photography as well.
Oh, sure, right, okay. So the Perseids this year, we were very fortunate to be at a very good place for watching the Perseids. The maximum was on 12th between 19 and 22 universal time, which translated into 10 p.m. till 1 a.m. Qatar time on August 12th. And August 12th was a Thursday. It was in Middle East, it was a weekend night. So I didn't have to take the day off from the work as well. So it was very nice. There was no moon as well. So we were expecting to see quite a lot of meteors this year. The meteors, one of the participants mentioned earlier, the speed of the meteors, this one's mostly were 59 kilometers per second. This was the Comet Swift-Tuttle, which came 133 years earlier in 1992. And next time it will come again in 2126. And when it comes in 2126, it will be a naked eye object. So that is something which, we can tell our great-great-grandkids that they should keep an eye out, because we won't be there most probably. So the observation, I did this observation from Qatar. Qatar is part of the Arabian Peninsula. It's a piece of land which juts out from the Arabian Peninsula, and its direction is exactly north and south. So one thing which I wanted to share was the light pollution map. There are a lot of lights in the region, although people think that it is desert, but still the street lights and the other lights are immense in Qatar and in Middle East. And the land is flat, so you get to see all the lights when you go anywhere else, anywhere in the country. So you might not be able to make out the Qatar map over here, but this is where the Qatar is. And this is all the light polluted area, the major cities and the highways. And my observation point was somewhere here. And if I magnify, this was my observation point from where I did the observation. And it is classified as a bottle 4 sky based on 2015 data. So it's somewhere close to bottle 4. And next, I'm just going to share some of the pictures which I took, and all these pictures are from this year's meteor shower. And later on, I will show you some of the equipment which I've used to capture these. So this was a very nice picture in which I got the Pleiades in the same frame as the meteor itself. You can see this meteor passing right above the sand dune. So it was a very nice setting over there. Here's another one, a very nice one, which I caught, and it underlined the Pleiades itself. And in this meteor, you can see the colors as well. It starts with the green, and then it moves to yellow and then reddish. So the Pleiades I've captured are very colorful ones, and I think I very recently started capturing these on the film. The previous ones I did were just 1 or 2 meteor showers, Aquarids and Geminids, but for some reason I did not capture the colors in those meteors. But in Perseids, the colors were very obvious. And again, this dune provides a very nice foreground to our starry nights here. This is by far the brightest one which I caught in this session. So again, you can see the Pleiades, you can see Taurus here as well. And then this is the meteor which is coming down, and the radiant is somewhere up there, pretty close there. And I'll show you a picture with the radiant as well. And the Orion is also rising. This is a picture with a fisheye lens that I have. So I used a fisheye lens as well, and it captured this meteor. It's difficult to tell because of the curvature of the lens whether it belongs to Perseus or not, but I think it does belong to Perseids because it is arcing like this over there and going towards Perseus. And along the way, you can also see that I captured Andromeda galaxy, and this over here is Jupiter. This is one more image which I wanted to show because it captured the light very beautifully, right? And in all these images, I've processed these images slightly in Lightroom, and I have oversaturated those images to bring out the color. So with the naked eye, it is very difficult to see the colors. At least I couldn't identify the colors. Maybe the colors were there. On the film, this was the most colorful one, but it is slightly saturated. And by saturation, I means that, I'm bringing out the colors. And even in this frame, you can see that Andromeda galaxy is over here. This is a collage which a friend of mine prepared from the data that I gave him. And he collected all those meteors and, attached them to a single frame. So this is not a very true representation of the meteors. The location of the meteors is appearing different with respect to the background stars, but their location with respect to the radiant is pretty okay. So you can see that all these meteors are pointing upward towards this point. And these stars, these are the stars of Perseus, and all these meteors are pointing to this radiant in the Perseus over here. And one thing which I learned in astronomy was to draw imaginary lines. So in PowerPoint, I used the actual lines to extend it. And you can see that all these are extending to the same point in the sky. So this is very interesting to see. And there are minor differences in the directions of the lines, but those are because of the geometric artifacts of the lenses that I used. So there would be some aberration in the lenses. So that would mean that radiant looks slightly off or not exactly parallel to each other, but actually they are parallel to each other. So these were the pictures which I wanted to show about the meteors and the meteor night. In that night, I took around 1,000 plus photos. And in those 1,000 plus photos, these are the best ones which I caught. There were about 5 or 6 others as well, but the meteors were very dim in those photos. So we did a full night of observation, and while driving back, I saw something very interesting as well, and that made me realize that that is the source and the attractor of all these meteors and the reason why we see these meteors. So yes, one reason is the comet that passed, but the comet came in because there's a great attractor which pulls the comets towards the inner solar system. And then the comet leaves and it leaves behind the dust trail. So I caught this picture on the morning, so which is not a meteor, but it is the great attractor of the comets through which we see these meteors. So this was the picture part of the presentation. next, as the earlier participant also explained the equipment, this is the equipment which I use. So I have a DSLR camera and then a tripod and an intervalometer. If your camera has a built-in one, fine. Otherwise, you'll need an external one so that you can take as many photos pre-programmed as you can. You need a lot of extra batteries as well, depending on what kind of camera you have, what is the weather over there, dark skies, and coffee, right? So I think the earlier participant mentioned that you need patience, but if you have coffee, then maybe your patience will increase a little more as well. So this is the setup that I have. I did not use a Star Adventurer or a tracker so far, but I learned that it is a very good idea to use it, because one thing which I noticed was that Perseids, due to the location of the radiant with respect to the Milky Way, they offer a lot of meteors which are parallel to the Milky Way. And those shots I've seen on the internet and others as well are very rewarding when you see a meteor going straight parallel to the Milky Way. So probably next time I'll try that Star Adventure that I have. This was the setup detail summary. I have a detailed one as well. If someone is interested, I can go into this. Otherwise, I think I'll just skip it if someone is not interested.
It's very interesting. You may proceed.
Okay.
Yes.
So I have a D7000 camera and I have two lenses. One is 11mm Tamron lens and the other one is 10.5mm fisheye lens. The fisheye lens covers a large amount of area, I think around 160 degrees, right? The Tamron, not that much. But the issue with the fisheye lens is that since it covers such a large area, the meteors appear very small. So it only captures the very large meteors and it shows them as very small meteors. But it is possible to catch meteors easily using it, right? And the Tamron gives longer meteors. It's still a wide angle one. The camera that I have has a built-in intervalometer, so I don't have to attach another intervalometer. It is good enough for me. I usually shoot in RAW with an ISO setting of 3200, manually focused to around infinity. And when I say around infinity, this means that you have to hit and try to make sure that the stars are pointy. If you just point it at infinity, it is usually not point stars that you get. This is something which you learn by hit and try. For the white balance, I prefer using 3600 to 4000 Kelvin. It gives a slightly bluish tinge to the sky, but you can also adjust white balance afterwards in post-processing. Then I simply set it to manual, 20 to 30 seconds, f2.8 or less aperture. The bigger the lens is open, the better it is. And simply point it towards the sky in the direction which you can recognize later on, or which would look nice in the pictures that would come out. So you can point it towards the Milky Way or Orion. Orion pictures, I've seen pictures come very nicely when a meteor passes right through Orion. And it's a very easy constellation to find as well. And that's about it. You need to have extra batteries with you because at least, one or two batteries you'll run out during the session. And then I do slight touch-up post-processing in Adobe Lightroom. So this was my setup details, and this was the presentation. One thing about color coding, these are the meteors that I showed you earlier as well. So what I've read is that I've read two counts on this, right? One says that the color comes from the material which is there in the dust. So if it has silicates, if it has other materials, so it will give off that color. And I think the color green is given by, I have actually forgotten what it was, by one of these. Probably calcium is the one which gives the green color. And then also when the meteor passes through the atmosphere, it ionizes the oxygen molecules, and that also gives the green color. I'm not sure exactly the Perseids are green because of that or because of the minerals or because of the elements that they have in the dust over there. But I was really amazed to see this green color. It's almost neon green. And then it doesn't turn just to yellow and remain there. It turns to yellow, and then the end you can see that it it becomes pinkish and reddish. So this is something which, you know, I want to explore more in my next Perseid shower, and maybe I'll have to use a lens which is not very wide, because less wider lens, as I saw the pictures, it reveals the pictures better, the colors better as well. Of course, it is easier to see colors in the pictures. If you ask me, I don't recall seeing these colors on the night. Maybe I'm not a very good observer so far, but at least I only saw what I remember as yellow meteors, right? Or maybe whitish meteors. And one thing about Perseids was that some of the meteors were ghost-like, that you would see just a point of light going down with no trail at all. But then there was some which had a trail as well, which persisted for maybe just a microsecond or something, or a millisecond or a few milliseconds. I did not observe any persistent meteor trails, which would stay there for 1 second, 2 seconds, 3, 4, 5 seconds. So then I was looking at the various catalogs, and I was seeing what next is there. So I've seen that, you know, the winter meteor showers are all washed out by the moon. There is one coming up in October, the Draconids. This is a different Draconids from what Alexander was saying earlier. And it's set to, you know, have a peak on the 8th of October in the evening, UT time. So which again is a very good time for Qatar. And the concentration or the count of the ZHR is very low. But the good thing about these meteors, what I've heard, I've never seen them before, is that these are very slow meteors. It's 21 kilometer per second as compared to the 59 kilometer per second for the Perseids. And the radiant is very high in the evening. So you don't have to stay late in the night to watch this. You can do an evening or an early night observation as well. And it would be interesting to see these meteors coming straight from the top of the sky instead of coming from the side of the sky. That's about it. And this is just a little bit about me. In the beginning of the presentation, I added 2 logos, but I did not say anything about those, but I just want to spend 1 minute on those. So you see last here, LAST, last stands for Lahore Astronomical Society. This is the astronomy society in my town. I'm from Pakistan originally, and I founded this society 30 years ago. And it is now going strong, and you would find many amateur astronomers from Pakistan on the forums as well. And they're doing a very nice job over there in spreading out the word on astronomy. And the reason that I found this nice location in Qatar, which is away from the light pollution, as I mentioned, it is not easy to find a location in Qatar which has less light pollution, is because of this group, which is called Qatar National History Group. So it's a bunch of enthusiasts that go out and explore nature. And one of the things that they explore is also the night sky. So because of them, I found this great location in Qatar, which is one of the 2 or 3 locations, maybe probably on the entire peninsula, where you can go and do some nice observation of the night sky. So that's about it. That's all from my side. Any questions or comments, you're welcome to ask.
Great presentation. Great presentation, Omer. Thank you for being with us. Thank you for sharing your images and your setup. We had a similar setup as well. I hope by next year to have some time and check these images. My images. We have a Nikon D7100. We set it up for 20 seconds. I started with high ISO, but I ended up with 1400 for some reason at the place that we were. And I also programmed it for 20 seconds, one second in the interval, and then started to, yes. And it happened, now Philippos will start laughing. As we had the Gamma Dragonid after the end of the session, we couldn't record it with Alexander. The first time it was a very bright one, and not an ordinary for the shower we were looking for. The same happened with Philippos last year. We had 3 cameras. We were capturing almost all the sky, and they were falling everywhere else except the place we had the camera on, and we were just ended up eating chocolates and suffering the cold. But also this year, I believe we captured some a few with the camera with the settings which are similar to yours. And what I also realized is good to make a nice time-lapse video from these pictures. So we're also about that. But I also used the safety, something for safety. I turned that on the Polaris, which is always a nice star trail. So that was the safe side. Some of them were going to fall that way anyway. So I had a safe picture. So that was my perception. The safe picture on the Polaris and opposite to the Radiant, trying to capture some coming parallel to the Milky Way.
Which I did not mention was that I also have two cameras. So on one I had one lens and on the other I had another lens. Then I have a daytime camera as well because bird watching is my other hobby. So I have actually three cameras. And my wife was asking the other day, how come you have three cameras? You only used to have one camera. When did these two other cameras arrive?
Yeah, that's the usual question from our wives and girlfriends. You spend money on equipment again? Yes.
They brought it accidentally from the courier.
Yeah.
Yes, like these emails we get lately, DHL is giving out some prices. Some prices, yes. Some orders that were left behind during the lockdowns worldwide. So we get this spam email lately that DHL is giving away things that were left in their bonded. Nobody asked for them during the lockdown. So we have these spam emails.
Okay, some more questions?
Alexander, I want to say something to Omer about the infinite focus. Omer, I don't know if you know it. I read about it about a couple of years ago. The infinite focus of a lens, it moves depending of the temperature. If you are using the lens 13 degrees Celsius and the infinite point is at that point, when you are using it and it's cold, it's gonna be or before or after. And I tried it and it's true. Even if you buy Canon lenses, it's also written on the manual of the lens. And that the infinite focus, it changes depending of the temperature of the area. So just for your information.
Yes, I believe that Omer mentioned that usually he said, although he set it on infinite, he had to adjust it until you get a great spot on the stars. This is what he said, I believe. Yes.
Yes, exactly.
Yeah, and it is interesting. I didn't know that it is temperature dependent. So it is interesting. And I don't know if it is, what is the range of dependency, but some of the pictures I took, even throughout the night, I noticed that there was a time where they were not in focus, and then there's a time when they're in focus. And I was thinking maybe I stumbled on the focus ring a little or something like this, but this might be the reason, because in the desert, the temperature drops very quickly at night.
Yes.
Yes.
So we have to check very often to see the photos. But
we have the same thing here. Sudden drop of temperature in the night.
Okay.
And humidity, lots of humidity.
Oh yeah.
Usually my infinite is a bit before. If it's a very hot night, usually my focal length is a little bit before the line of the infinity.
Yeah.
But usually I check it also with 1 or 2 photos before I start taking the rest with the intervalometer.
Can you use a Batinov mask like you do on a telescope lens? Because I use that and it changes, especially here in the UK, it changes when you get the dew point. in the night. So you start at 11 and you're on one focus point, and then as the dew point is reached, it can change quite dramatically. So I use a Batinov mask, which you get the spikes on a star, and you can get that pinpoint accuracy. Yes, you're quite right. I mean, on a camera, the infinity is nowhere near often where the actual infinity point is. So yeah, Batinov mask is an answer to that, I think.
Yes.
Philippos?
Chrismo, for shorter focal lengths, it's not really necessary, because now I'm also using a telescope, and as you know, focusing a telescope, it's really hard. But when you are using shorter focal lengths, let's say 15 mm on a camera, it's very easy to focus. There are 1, 2 tries, it's gonna be okay. It's not like the telescope that you have to play
And
with the
really
focuser and go back.
Yeah.
Yes. With the lenses, it's easy. And there are even some cameras, actually my camera is old. I saw some new cameras that they can even autofocus on a star. So for me, it's impossible. But the new cameras, they found, let's say, Jupiter, they autofocus there, they put at the manual focus, and they start to take photos. As simple as that.
Okay.
But for the cameras, actually, you are zooming the live view, and you are trying to get the round star that you want. After that, you're okay. It's not hard at all. It's not like the telescopes that for the telescope, you might take 100 photos and then you realize that you're out of focus. For the telescopes, you really need the Batinov mask. But for the lenses, I think it's okay. It's not very hard.
A Batinov mark for the lenses, for the cameras?
Batinov mask, as Mr. George said, is you put it in front of your lens, and as you are focusing, you are having spikes around the star, and you know that if the spikes are equally spread, I said it correctly, Mr. Chris?
Yeah,
yes, if they are equally spread, it means that you are focused.
And you can get very accurate. So, but Philippos says, it doesn't vary an awful lot, but if it varies because of the temperature, then one way or another you need to keep refocusing. But but maybe it's not as critical as it is on the telescope. Actually, Philippos, can I ask you a question?
Yes.
How do you set up the Star Adventurer when you're doing? Do you have to still polar align, and then do you point it to a particular point in the sky and then set it to run sidereals, or
Mr. Chris, the easy part of the Star Adventurer is that if you are using a wide lens, there is no reason to make a polar alignment. You are standing on top of the Star Adventurer, you see Polaris, and with the eyes you put it at the same. The polar scope, it faces Polaris. But if you are putting a telescope or a bigger lens, you have to polar align, and it's very difficult.
Yeah.
The Star Adventurer, because you will prepare everything, you make the polar alignment, then you will put the camera and the telescope, and all of a sudden the polar alignment is wrong. You have to take everything off again and try to fix it and put it back, because it's not heavy. It doesn't. If you touch it, it will move.
There's no counterweight, but now Philippos with your
there is counterweight. There is counterweight.
Yeah.
yes, but now with your
there is.
EQ6, we're going to have more fun.
Tell me.
Now with your EQ6, we'll have more fun.
Yes. I keep it for me at the moment. I shared it with you, but it's okay.
Now everybody knows.
Okay.
Okay, some more questions to.
Can I just very quickly. So on that point, then, do you keep the star tracker in one position, or does it move with sidereal rate? So are you tracking?
No, it's tracking. It's tracking normally.
It's tracking.
Siberia.
Yes.
It's
tracking.
tracking
Siberia already.
sidereal. All right. Okay. Yeah. Okay.
Okay, some more questions to Omer.
It's very useful when you want to take pictures of the radiance with the short meteors and faint meteors. Very nice. And then you can do a stack up with the meteors.
It was very helpful when we went for the Geminis.
We captured all planes. We captured all the planes, Omer. Me and Philippos, we captured all the planes.
Yeah, me as well. Satellites. I captured a lot of satellites.
Satellites, yes.
If you check the picture above us, the
Yeah,
one
yeah.
that behind us, yes.
Yeah, that's a lot of.
Yeah, a lot of.
It means that we are not far from the airport. That's all. Okay, thank you, Omer. Let me proceed. Our program is just a bit left. So that's what we might do for future. Aurigids, they produced, as you could see, 150 meteors per hour. It was just during few hours, about an hour, something like that. And for this year, it is predicted from 50 to 100. Night will be from 31st of August to 1st of September, and I wrote Cyprus time. I don't see it here. I covered it. So 21 o'clock universal time. So it means that midnight in Cyprus. So it's more or less possible. And the difference of 50, 100, it's because of no one knows precisely. We have not six, we have 3 predictions, and they differ in numbers and time. Time is about the same, just during half an hour difference, but the zenith per hour rate differs. What does it mean, zenith per hour rate? You saw it constantly, starting from Matvey talk. So it means that when radiant is precisely over your head, then during an hour, if activity is the same, it's half an hour only. Well, but if activity is the same during an hour, you will see 150 meteors on dark sky. And definition for dark sky is limited magnitude 6.5. So it's theoretical. That's why it's written corrected hourly meteor rate. So it's theoretical. So in fact, we don't have so dark sky. In fact, radiant is not in zenith, but as Matvey started, very low near horizon, and so on. So that's what we have in reality. But numbers are impressive because of some years, Perseids were just 80, like previous year, for example, there were just 8 meteors. This year they produce all the peak. In 2 days later, they produce 150. Matvey shown us this picture. Okay, what do we expect for Aurigids? This one, and what we really have. This is a planetarium program for 1st of September, 30 midnight Cyprus time, so from 31st to 1st of September. And what do we have? Just half an hour earlier, around half an hour, let's say 15-20 minutes earlier, the moon was on horizon, so it was just moon rising. And it is that very moment when some prediction said that it is maximum. So the radiant is low for us. The moon is near to it. We may wait a bit later, 1 hour, 2 hours, 3 hours, yes, but the moon is next to it. So it means that not much fun at all. Either it is low or higher, we still have completely illuminated skies this year. That's why I recommend to take images of the whole sky camera, which has more patience than humans. Just to watch, like Matvey made in 45 minutes, 1 meteor. So it's something that what we could expect for this 50-80 with light, with bright moon next to it. So that's why if we wanted to do some science, and the International Meteor Organization wrote, all reasonable data are welcomed. because of it's really interesting the fact that we have prediction. We have even 3 different predictions, and which of them or none of them is the realization is really worth to know. That's why it's worth to make observations of it, even if it is so low for us. But the better is take photographic, because of I already explained. For visual observations, it's not much fun. Very low light and bright sky. So our next meeting will be in 2 weeks, exactly when we are waiting for this maximum. So, but in evening before maximum for Aurigids, and it will be about all sky cameras and triangulation of meteors. It will be given by Professor David Rees from the Great Britain. So everyone is welcome.
Well, guys, questions, suggestions? Omer, please prepare something for Arabian Nights and your 2 clubs. We would love to hear about it.
Okay.
Send us an email. You can have Karen can give you my mobile number. I can write here for you on the chat.
Thank you.
And the website, and on the top right corner of the website, links to the group, to the YouTube channel, Instagram, etc. And you'll find all announcement in the main page. We are rebuilding it. So love to keep in touch and we have cooperation. Alec Kriglia, welcome as well. You are always welcome to have another speech. Thank you, Yoria, for your good words. Philippos, Pattichis, always valuable knowledge from you. Thank you very much, Chris. I love that for the background. I love it. I love it. Share it, please. Share it on the group.
Oh, yeah,
group.
all right.
Lisa, thank you for joining from the States. Matvey and Leonidas, great presentations. Georgia, thank you very much. So guys, see you in 2 weeks' time with a very nice presentation from Professor David Rees. He's a doctor as well. He has a lot of expertise and a lot of knowledge in all sky cameras. He was in international projects and scientific projects. He's going to give a lot of information about using all sky cameras and the triangulation of meteors. So we're looking forward to it, and hopefully we're going to have our all sky camera on online and share our observations from the all sky camera as well. So keep in touch.
Thank you very much, George.
Thank you.
Nice seeing you guys.
Bye-bye.
Thank you. Bye.